Pop culture gives us a very specific picture of the bear, a roaring, violent apex predator standing on its hind legs, ready to strike. But watch a bear in the wild and you see something entirely different. They walk slowly, they rule quietly. Roughly 20 million years ago, the ursine lineage made an evolutionary pivot. They stopped functioning purely as specialized carnivores, adapting into omnivorous generalists. Their massive skeletal structure, which you can clearly see in this upright framing, was built for heavy, methodical labor over high-speed chases. This broad diet gave them a massive survival advantage. By consuming whatever was available, plants, fruits, insects, fish, and occasional meat, they could endure the severe climate shifts and prolonged periods of scarcity that starved out more specialized hunters. Their entire physical architecture centers on a single biological philosophy: long-term endurance. They evolved with advanced fat storage systems and dense bone structures designed to outlast environmental extremes rather than conquer them rapidly. This slow, steady endurance turned them into living ecological infrastructure. Over millennia, bears integrated themselves as deep maintenance engines, quietly shaping and sustaining massive landscapes. The most extreme example of this endurance is hibernation. We often think of hibernation as a long, deep sleep, but physiologically, it is a state of near-complete biological suspension. This visualization compares a standard mammalian metabolic rate against a hibernating bear's baseline. While typical mammals quickly deplete their energy reserves, the bear's heart rate drops drastically, allowing them to survive for months without consuming a single calorie or drop of water. As the timeline progresses, notice how the variables for bone density and muscle mass remain completely flat. Despite zero physical activity, they experience almost no muscle atrophy or bone loss, a medical impossibility for almost any other mammal. Researchers actively study this hardware today. Understanding how a bear preserves its physical structure during months of immobility holds direct medical insights for treating human osteoporosis, muscle degeneration, and the bodily toll of long-term space travel. This ultra-efficient physiological system lets the bear wait out the planet's harshest extremes, preserving its own life without draining the ecosystem's severely limited winter resources. Physical hardware requires advanced mental software to operate. Bears are solitary creatures, and as you look closely at this profile, you see an incredibly observant, strategic thinker. Their neurological traits include an exceptional spatial memory. A bear can recall the exact location of seasonal food sources, complex navigation routes, and even specific human encounters across vast territories, retaining that information for years. They use this cognitive map to constantly assess risk. They are boundary-driven animals, programmed to avoid unnecessary conflict. Unless cornered or defending young, their primary psychological directive is de-escalation and evasion. They also display deep emotional complexity. Mother bears form intense maternal bonds that last for years, resulting in some of the most highly protective parenting behaviors found anywhere in the mammalian world. This self-regulating mental state means they do not rule the forest through brute violence. They navigate it through supreme spatial awareness and careful, deliberate decisions. When you combine that physical endurance with a precise mental map, the output is constant, active ecosystem engineering. Bears are keystone species, and their daily habits physically reshape the world around them. The clearest example of this engineering happens every year during the salmon run. Bears rely heavily on these fish to build fat reserves, pulling thousands of pounds of marine nutrients entirely out of the river systems. This topographical map traces where those marine nutrients go. Through the bear's digestive system, nitrogen and phosphorus are transported inland, blooming into massive fertilization zones miles deep into the forest soil. As the bear continues its inland migration, it performs localized maintenance. They dig heavily, aerating the topsoil. They eat seasonal fruits, scattering seeds across large territories, and their selective hunting keeps local prey populations balanced. Without this continuous, methodical labor, the forest loses its primary nutrient circulatory system, the soil loses its fertilizer, and the entire ecosystem begins to stagnate. Today, that ancient biological engine is colliding with a rapidly fragmenting human world. Hard boundaries, like this road construction cutting directly across historical migration paths, abruptly sever the continuous zones bears require to operate. Rapid climate change acts as a severe system disruptor. Unpredictable seasons and melting ice confuse hibernation triggers and destroy the stable environmental baseline these animals evolved to rely on. Bears attempt to adapt. They alter their movement patterns and even learn human waste schedules to survive in shrinking habitats. But biological flexibility has its strict limitations. A declining local bear population serves as a literal alarm bell. It indicates immediate forest stress, an imbalance in prey species, and impending nutrient starvation across the surrounding vegetation. True coexistence requires wildlife corridors and protected zones that give bears the space and continuity they need to function. Preserving the architect is the only reliable way to prevent the forest from unraveling.